how do you program the 8BitCADE Excel? Well, what type of program do you want to do? Well, there tends to be three main types of programs that you'll apply to the 8BitCADE Excel. One is a single sketch, one is an image which contains multiple sketches, and the other one is a bootloader program. So we're going to discuss how all of those three are different and how they may require different connections and use different serial protocols. Now before we do that, let's just make sure that we can all recognize exactly what's on the screen. So what we have is the back of the 8BitCADE Excel. You can see that this is our Pro Micro board here with our USB connection that we connect to a PC. And if we have a look here, we can see we have an external memory chip. Now the external memory chip is used to store data, and we tend to write, the type of data that we write to that chip is normally an image. An image essentially is a group of sketches, and the group of sketches that are if you like highly organized. So this essentially will be your games image. So it could be your 200 or 300 games with what I would call category splash screens, all organized to allow it to be selectable. The next thing you might do is you might load a single sketch. A single sketch, if you were loading a single sketch, you would load it via the USB connector. And that single sketch would be loaded onto your 32U4, which is the microchip that's based on your Pro Micro board. So that's an 80 mega 32U4 chip, which has essentially program memory that you can write a single sketch to. So here we have a group of sketches, here we have a single sketch, and when you're writing to both these chips, you actually use the USB connector for programming purposes. Now we also to implement our game's image, we have to have a modified bootloader program. Now the modified bootloader program is located in the same place, which is your program memory on your 32U4 chip. But on Arduino microcontrollers, they tend to protect the bootloader program to stop beginners from accidentally damaging or overwriting it. So you have a completely different connection to your bootloader sector on your program memory chip, and we call this ICSP. An ICSP is an in-circuit serial programmer connector. It's a 6-pin connector, and we attach essentially another microcontroller to that connector so that we can reflash the bootloader sector within your program memory of your microchip. So there's just overview. We've got a USB connector which we can apply a single sketch into the memory, or we can update using a games image, which is like a compilation of games, to access our 16 megabyte external flash memory chip. Or if we want to access the bootloader, then we have to use our ICSP connector using another microcontroller to reflash the bootloader sector, which has to be done very carefully so you don't damage it. And we have this special connector on our 8BitCADE which allows you to do that. You just need an external programmer, which actually are very reasonably priced. They're very, very low cost programmer, because it's essentially another AVR chip on a board that you use to flash the bootloader program. Okay, now to flash your ICSP programmer, we use a protocol called SPI, Serial Peripheral Interface, which is a 4-wire type of serial protocol. So just be aware of that. We call it 4-wire because we have 4 main connections plus ground plus VCC, and SPI is described in the 8BitCADE Excel part dictionary. So if you want to learn about the different protocols that these boards use, then have a read of the part dictionary, and it fully explains I2C and SPI protocols and UART as well. So let's now look at the actual program memory sectors. So if you have a look at your program memory sectors here, this is the actual 80 mega 32 U4 chip, or certainly similar to, at least. So this gives you an overview of a AVR chip, if you like. Now, if you can see here, where we have our Arduino sketch would be in our program memory here, and we would access that via a USB connection from our PC. Now, built inside the 32U4 chip is a UART bridge, which essentially converts USB serial into Arduino serial, which is essentially TTL 5-volt logic, because USB serial is actually quite different with respect to things like voltage levels, etc. So that has to be converted. Now, we're very lucky because the 32U4 chip has that UART built in. So inside this microchip here is actually a UART. In fact, there's 2 UARTs situated inside that microchip, and that actually converts USB serial into what we call, in really simple terms, Arduino serial, which is TTL logic. Arduino works on a serial that's very, very old, tried and tested, and works really, really well. But of course, USB has been updated. It's very, very modern, and so essentially we have these 2 protocols, serial protocols, which are very different, and so we have to have some sort of bridge to convert them, to make them readable within the actual microchip. Some Arduino boards have another microprocessor here called a FTDI chip, which will convert USB serial into what I call Arduino serial to make it compatible. We're very lucky. We have a 32U4 chip which has a UART bridge built inside it, which is one of the strengths of the 32U4 chip. Okay, so when you're writing a sketch, an Arduino sketch, you're writing it to your 32 kilobytes sector of your program memory. The bootloader is also situated in the same part, but it's protected, and you can see that dashed line here, which denotes that it's actually a protected sector of that memory. And to access it, we have to use an external programmer called an ICSP, an in-circuit serial programmer, and we use our ICSP connector for that. We're using SPI serial to do that, which requires these types of connections, which is later explained and demonstrated on how to connect and flash the bootloader. And we're writing data to the program memory sector here, which is, I think, about 2 kilobytes in size. So out of the 32 kilobytes that you've got in program memory, about 30 kilobytes is available for your Arduino sketch, and 2 kilobytes is used by the bootloader. We also have SRAM, our static random access memory, essentially data variables within your Arduino sketch, which have to do things like calculations or temporarily store information while the power is on the circuit, is stored in this sector of your memory. Anything that needs to be long-term stored but needs to be able to be updated, for example, things like a high score of a game, would go into our EEPROM memory, which is only 1 kilobyte in size. I think on this particular chip is 1 kilobyte in size. So for things like variables like the position of a character on a screen, would go into your SRAM. The actual program, the actual sketch program, would go into your program memory. High scores that need to be kept so that when the power is turned off and turned back on and displayed would go into your EEPROM. And the bootloader goes into a specially protected sector of your program memory. And that's essentially how your memory sectors of your 8BitCADE Excel are accessed. And I say this is all written in your 8BitCADE Excel part dictionary, and so for review. Okay, so here's your 8BitCADE Excel, and if we turn the 8BitCADE Excel off and just have a look at the back, we've got the ICSP connector. The ICSP connector is the connector that we need to attach our external programmer to be able to program the bootloader onto the ProMicro. So the ProMicro is just here, and to access the 32U4 chip inside the ProMicro, we need to use the ICSP connector here. Okay, now just to give you a breakout of the connector, and we'll do that on the screen. So here we have the connections are as follows. Okay, so now we're going to look at the actual Avr Isp Shield. We tend to recommend the DIY more Avr Isp Shield here, only for the simple reason is you can do lots of different things with this particular shield. So if you have things like an 80 mega 328p microchip, then you can program them, the chips off board on here. You can program sketches, and you can also program access boot sectors for the AVR chips via the ISP 6-pin header here. This is the one we're going to use for the 8BitCADE Excel, this connector here. To use the Avr Isp Shield, we attach it to an Arduino Uno because we use a microcontroller to program another microcontroller, and that's how we program the bootloader for the 8BitCADE Excel. So to do that, all we need to do is place the shield lining up the header pins, making sure that your 6-pin connector is connected here accurately, and gently close it up. Now we need to match the connections from your ISP 6-pin on here to the pins on here. So I'm going to go for the ground pin first. The ground pin is brown. I'm going to have a look on my connector here, and I'm going to fit my ground pin on. So you can see my ground pin is my first connection on here. Okay, so the connections have all been placed onto the 8BitCADE Excel, and we're going to go through those connections now. So first connection here is ground, second connection is reset pin, the next connection is your MOSI, master out slave in connection, the next pin is your clock signal. We call it SCK or SCL, but it's your clock signal. Your next pin is your VCC, which is your 5-volt input, and then your last connection is your what we call MISO, which is master in slave out connection. So that's the connections on the 8BitCADE Excel. Just to make sure that you've got the right connections here, you've got ground to ground connection, MOSI to MOSI connection, 5V to VCC connection. You also have reset to reset connection. SCK goes to SCK SCL on the actual 8BitCADE XL connector, and you've got MISO, which is MISO to MISO, which is master in, slave out, and that's your standard SPI connectors for the 8BitCADE XL. What we tend to do as well is, once that connection's done, is put a little bit of tape around it so it holds the connectors nice and flat and sort of binds them together. So if you ever need to program the bootloader again on the 8BitCADE XL, you can just apply it. And we tend to do the same here as well. So that way we can create, I suppose, what you call a small mini loom. It's easy to plug in and plug and take out, as opposed to having to keep checking the connections. We then apply this to our, plug this into our USB connection on our computer, and use the Arduino IDE for programming, which we'll do now. Okay, if you're using the Avr Isp Shield for the first time, then it actually makes sense to program your Avr Isp Shield Arduino Uno first of all, to make sure that it's got the right information. So what you have to do is you have to, or the right sketch to program your bootloader. So what you have to do is you have to open up the OpenSmart folder, and you can download this folder from the 8BitCADE website, or you can just search it online, OpenSmart ISP. So what you need to do is open the OpenSmart ISP sketch. This is, so what you're actually going to do first of all is open up the ISP sketch and use this sketch to program the Arduino Uno that the Avr Isp Shield is actually attached to. So to do that, we actually then go and program. We need to just program it as a normal Arduino Uno. So we go Uno, COM21, and we're going to upload it as an Avr Isp Mark II. So we're not burning the bootloader yet. This is only have to do this if it's the first time you're using your Avr Isp Shield, or you're using it on a brand new Uno. So I'm now going to compile, and then I'm going to upload. Okay, so that's now programmed our Arduino Isp, our Uno attached to our Avr Isp Shield. So I can now close that, and now I want to load our Arduino 3K bootloader. Again, you know, this is I've saved mine as a sketch, but the reality is I've only saved it as a sketch because I wanted to save the settings, the hardware settings. So you can see there's nothing in the sketch because we're not actually uploading the sketch. We're actually uploading a bootloader that's saved in the library file. So what I'm going to do is show you exactly where that is. So I'm going to go to my homemade Arduboy. I'm going to go down to SparkFun, ProMicro, alternative wiring, Arduboy optimized core, because that's what we'll be using, SSD 1309 because that's the type of screen we use, Cafe 3K bootloader. That's the correct flash select pins, and that's the correct port, but we want to now program it as an Arduino as ISP. Okay, so I'll go through those settings one more time just to make sure they're all correct. Arduino as an ISP, and then I can click Burn Bootloader. And the bootloader's now been burned. Okay. Right, so now if I unplug, there you go.